Okay, welcome back to my YouTube channel. So now I have a question on integration by parts. I want to quickly tackle this question because this question is a piece of cake. So now let's follow it up. We have solution. So I'll be teaching you, if you stay tuned to the end of this video, I'll be teaching you how to solve this question the normal way, and the trick. The trick to get the answer to this question in few minutes. Approximately 1 minute. So now let's go. We have this. So for you to integrate this, we need the formula. What does the formula says? It says that when we have to integrate two functions, let's say u and against dv, u against dv is equal to uv minus the integral of v du. This is the sweet formula for what? So this is the formula for integration by what? By parts. By path. So this is the formula you are to what? Apply. Let me make the integral to be smaller. Integral of what? V du. Are you understanding this now? So what it's telling you is that if you have the product of two functions and you're integrating them, what I mean is that for you to integrate this now, you are integrating u and dv. dv and u, they are two different functions. You understand? So you are integrating two functions. Where we're integrating one with respect to the other. We're integrating one with respect to what? The other. In that case, you implement this. You what? Implement this. Now let me show you like what the first step you have to take in this is to, the first step is to assign value to what? To you assign value to your what? To your u and your dv. So assign. That's step one. Step one says assign values to u and dv. And what? Do you agree? So inside those two functions that are multiplying each other, I hope you know that this guy, this formula here, that is equaling all this stuff. You understand? You know that do you know that it can be likened to this? Are you watching? This can be likened to this. So you discover I can take this as u, and I can take these two as what? As dv. Do you understand? So in that case now it is standing in for this. It's standing in for what? For this. Now, but I will give you a rule on how to what? Take which one, the rule on how to know which one is u and which one is v, and that rule is based on what? An acronym called what? Let me say, assign this to this based on what? What are we basing this on now? On Liates. On what? Liates. What is the full meaning of this Liates? Liates is what? Logarithm. Let me just draw that down. Logarithm, this is inverse, so inverse functions of inverse trig functions. You understand? This is what? Algebra. This is trigonometry, this is trig, and this is what? Exponential. This is what? Exponential. That's what it stands for. So meaning if you have functions or two functions multiply themselves, you understand? In this case, you follow this. So assuming in this case now that we have, assuming in a particular case you have two functions, but in this case, we have two kinds of functions that we already know based on this. What would you say the two functions we have here are? What are the two functions we have? Exponential. Look very carefully. Algebra, God bless you. Algebra and what? And trig, not logarithmic. You understand? So Based on this now, if you have two functions, you should follow this rule. But want to explain based on what we have. Want to explain based on what we have. I'll have these two, right? So which one comes first? So the one that comes first, you take what? Is it U or V? U. Take note, it's not V that we are assigning. U and the V. You understand? So the first one should take what? U. The other one will not take what? The V. So based on this now, therefore, or I can say thus, U equal what? X cubed and dv equal what? Sine. Do you agree with me? If that is the case, what is v? What is v? If I find the n times derivative of this, if I have this now equals sine x, take note, dx is among it too. Dx. Are you understanding this? If I integrate both sides, if I what? I'll have, what can I put here? If since nothing is here, I can put what? What can I put here? What number can be here that can multiply is dv? Assuming, before I integrate, or when it was here, what number can I put in front of here as the coefficient? Beautiful, God bless you. So 1 was here. So meaning if I integrate, there should still be 1 here, right? If you integrate 1 with respect to v, what will you get? Let me know who knows about integration a bit. If you integrate 1 with respect to v, just like if you integrate 1 with respect to x, what are you supposed to get? Yes, you get what? V. Are you understanding? So let's say we have what? 1, and you're integrating with respect to what? Anything. Let's say x. If we say x now, it means that what? We're having 1x is over 0. Hope you agree. So by integration, we'll say we'll add 1 power, right? And divide by that stuff, right? So in this case, now we have what? 1 what? X what? Over what? 1, right? Which will still give you what? X. So if you implement the same concept here, what will you still get? You will still get what? V. You understand? In this case, our own will not be what? V raised over 0, you add 1, and you add 1 here. Do you understand? Okay. Please, if you don't understand, you can ask questions. No, don't just keep quiet and be looking. So, I'm just explaining to you why if I integrate 1 here, I'll have V. You understand? Because if you integrate any constant, you should have the value in which you are integrating with respect to attached to it with degree 1. You understand? If you integrate any constant, I repeat, you should have the value which you are integrating with respect to just attached to that constant with a degree of what? With a degree of what? With a degree of what? 1. So this is like saying 1v, right? So I'm attaching the value which I'm integrating with respect to the constant, which is 1, but the degree is what? 1. So I showed you the process in which it followed. I showed you the what? So if we have this now, if we integrate sine x, what we have? Cos x, because integral or integration means it's just directly opposite of differentiation. So it means what did I do? What did I differentiate to get what? Sine. Okay, and it turns out that what you said is wrong. The answer will actually be minus cos. Because if you find out what did I integrate to get sine, you discover that what did I differentiate to get sine? You find out that if you differentiate cos, you cannot get sine. You understand? So you can't outrightly say that what you differentiated to get sine is cos. Rather, you put what? Minus to that cos. So that when you differentiate it will give you minus sine, then the minus that you put initially will multiply it to get what? To get sine. Do you understand this? Do you understand this? Okay, so that is what? As simple as that. So it means that we have cos x. So what do we integrate? What did we integrate? What do we differentiate? Sorry, what do we differentiate to get sine? Is what we are looking for by saying we are integrating what? Sine. Anytime they say differentiate, integrate this. Anytime they say integrate this, I repeat. Anytime they tell you integrate this, it means you should ask yourself, for me to integrate this, what I must get must be equal to what was differentiated to get that thing. So if I'm asking you to integrate cos, you ask yourself, if I'm integrating cos, what should I differentiate to get cos? What should you differentiate to get cos? sine. If you differentiate cos x, you get sine x. So it means that the integral of what? Of cos x is what? Sine x. Do you understand the concept of integration? Based on that, let me ask you a very simple question now. Let's have this. If we have 2x, and I ask you to integrate 2x with respect to what? X, what will you get? What will you differentiate to have 2x?
X squared.
No, you should go to the answer. X squared. That's the answer. So you can easily do it if you want to follow the process. This is a polynomial function. You have 2x, add 1 to the power, right? And divide by the whole stuff, right? Which is 2. This it can still be said to be all 2. So 2 we cancel 2. That's how we got that. Are you seeing it's very easy? It's what? Very, very what? Easy. So we can clean that out. We can what? Clean that out. So now we have this as what? Our V. Our V. What about our du? What about our du? What will our du be? 3x squared. Hope you know what differentiating now. Dx. Because we are differentiating u with respect to x. And if I cross multiply, the dx will go here. Hope you understand. So you will not be confused. You understand? Our differentiating u with respect to x. It's not the du dx, right? We should give it 3x. If I cross over, the dx will come in. Do you understand that? Beautiful. I want us to be following. So therefore it means that the integral of x cubed sine x dx should be equal to, what will it be equal to? What's our u now? Our u is what? S cubed, and our v is what? What is our v now? Minus cos. Please look at the board before you talk to me. Minus, what next? Integral, what is our v? Minus what? Cos x. What is our du? 3x squared dx. Is that all? That's all. So now, how do we simplify this? So I won't be writing this again, so it will not be long. So this should be equal to what? Minus x cubed cos x. Hope you know, because of this minus coming here, right? Do you understand? X cubed cos x. Then minus. Hope you know, because this minus is here. You understand? And minus is not, you can't integrate minus, so it can come out of the bracket. Do you understand? This minus can come out of the integral, sorry. So if it comes out of the integral, multiply the integral, it will become plus. I'm telling you what I'm doing now. So now integral of cos x 3x squared dx. Is it clear? Please, is there any question? Okay, so a question, you said you didn't understand the last part, right? The last part, look at what we did. Okay, but do you understand how we got all this stuff? Or do you understand it also? We just put in values now based on this. We have gotten our u. We carry our u. Where is our u? This, and put the v, ordinary v. We got this. We put it here. Abi? Then v is here. We take the v. Where is the v? This is the same guy. We put it. And the u. Where is the u? The u is all these things. We put it. That's all. We are just substituting values. Do you understand? We are not done yet now. So here now, I'll now give you any question. So here now, I'll now give you minus x cubed cos x plus. I've told you how I got the plus. There's minus here, and there's minus inside here. And this minus now, we are not integrating, so it can come out. On coming out of this thing is written under minus. Minus will give you what? Plus. Are we there? This will be integral cos x 3x squared dx. So are you observing something now? What are you observing? What can you observe? What can you observe? What can you observe from this? There is still an integration again, following the same order. Following the same what? So that's why they said we should what? So they told you, they give you a hint. So it means we implement the same concept. What? So here now we have minus x cubed cos x plus. Now this place will be, we'll take with the same format. This is u, this is dv, abi? Right? So I will implement it direct. I don't want to waste time. So it means if I'm implementing it now, we have our u. What will our u be? We have said our u is 3x squared, right? Now, v, what will v be? Integrate this, abi? Integrating this, what will you get? Please, can you call values for me? Sine x, because what I will differentiate to get cos is what? Sine x. Beautiful. Then minus integral. What's our v? Are you sure? Sine x. Now, du, what will our du be? Remember, our u is this. So if you differentiate, so it will be what? 2x. Ordinary, right? Wrong. It will be 6x. Because this will multiply this. Don't make that mistake. Then dx, right? Hope you know we are good. Are we good? Any question? Or you ask? I can't hear you. Speak up. The 3? Yes. No, they shouldn't be. There shouldn't be. You can factor out the 3 and solve. Yes, beautiful. Very, very beautiful. I should have brought out this 3 here. But I don't just want it to be more complicated. Let me just leave it inside. You understand? But if I keep pushing out values, some people become confused. You understand? But just leave it with time. You familiarize yourself, then we can be doing that. Now, we have the next to be what? We implement it the third time. Hope you know. We already have minus x cubed cos x plus. This place, since it's positive, I don't think there's any problem because it's still give it the same thing. So I have 3x squared sine x, right? Then this is minus, right? So minus, I'll work on this again. Now what? I'm working on this now. What will I get? I should still know my u and my what? dv. And my what? So what is my u according to the question? U is 6x in this, according to the formula, sorry. This is what we are looking at. According to the formula, we are following this. Now, 6x, what about dv now? We are looking for v from dv. Integrate this. Minus cos x. Minus, based on the formula. We are implementing the same formula. At each case, we get stuck and we are having the same scenario playing again. You understand? So, we'll take this as if it's a new question and implement this formula. Do you understand? Beautiful. So, now we have this as the integral of what is our v? Minus cos x, right? What's our du? It differentiates u, which is what? 6 dx. Beautiful. So we'll carry on with that and get that. When we simplify it, what will we have? We'll have minus x. Please call values for me. Call values for me. Cos x next plus 3x squared sine x minus, right, into 6x. Let me bring out the minus on at the other side. Cos x, that's minus 6 because of that minus to come out, right? Then minus, and we want to still integrate. I can bring out the minus and become plus, right? Because this minus here can come out. We are not integrating it. This minus here can come out, right? So now we have integral cos x what? Multiplied by what? 6 dx. From this place, hope you know this is now sweet. This is now what? Sugary is what? Sugary. So now let's go. From here now, I can now what? Write down. Write down. This case, do I need to apply integration by parts? Let me know how smart you guys are. Do I need to apply integration by parts? Why? Who can tell me why? Because there's no integral. There's integral. Now look at the integral of this with respect to dx. Come place u because there's no x attached to 6. Since there is no x attached to 6 has become a constant. Are you understanding it? Why we are applying it all this while is because something is attached to the constant, so it becomes a function. Whenever x is attached, a variable is attached to a constant, it becomes a function called polynomial what? Function. If the degree is 1, it becomes what? Linear. If the degree is 2, it becomes quadratic. If the degree is 3, it becomes normal polynomial. We call it polynomial. And upwards. And what? You understand? So once the x was, taken out, we can't apply integration by part again. We don't need to. You understand? So we have that. So finally, I shall have minus x cubed cos x plus 3x squared sine x minus into, let me still leave everything inside the bracket so that at the end of the day I can just multiply through by what? Minus. Or then what this has what? Minus 6 what? X cos x. Then this will give you, what will this thing give you? If you integrate cos, what will you have? What will you differentiate? So sine is what you differentiate to get cos. That means it means the integral of cos is what? Sine. Are you understanding that? So if you do that, remember, I should have even factored out this 6. Anytime you have a 6, you can bring it out of the integral to be here. Do you understand? So after integrating it, I'll just multiply by that what? 6, yeah? Are you understanding it? Then at the end of the day, I should add plus what? C. Why am I adding plus C? Because it's an indefinite what? Integral. It's what? An indefinite integral. So this is like our final what? Answer to this. Our final what? Answer to this. So what you are supposed to do is to simplify this, is to make it look simpler. How do I make it look simpler? I have minus x cubed cos x plus 3x squared sine x, then this multiplying this will give you plus 6x cos x minus, you understand, 6 sine x. I should have done that before I add the plus c. So now you are turning the plus c to minus. Do you understand? I should have done everything before I added plus c. I should have done anything before I what? Added plus c. So this is the final answer. Now let's go for the what? The very quick shortcut to this. Okay, we want to apply the shortcut to what? To what? Integrating this value, right? To integrating this. So for us to integrate this, there is a very short method. And that method is what? By the Liates. The Liates is a tabular method of what? Integration by parts. Right? Now, what do we need to do? We need to what? Draw the table. We need to what? Draw the table. And the table has three columns, right? The first column is for what? The sine. The what? The sine. Sine, I mean as in sine. Your normal sign, plus or minus. Then the next one is carrying what? The derivative. And the third is what? The integral. Or you can say this one is what? Your u. And this will be your what? Your dv. Are you understanding this? So it means since it's integral, it's not the integral of what? That, right? You have to integrate it. You understand? So now let's see how this will be. Now, coming to this portion now, according to Liates, which one should be our u and v? Now let me explain why. The reason is because in Liates, we have that this is logarithmic, inverse, algebra, trig, and exponential, right? So we can see clearly that what? Your algebra comes before your trig. That's why we're actually making u as what? X cubed, because x cubed is the algebraic part. Algebra now x algebra. So that is the what? Algebraic part, and it comes first according to the what? The Liates. According to the rule. You understand? According to what? The preference. The what? The preference. This is the preferential what? Acronym for what? For choosing what? These values, right? So now we have that this comes first before this. So we take this as u and this as what? dv, because it comes first algebra before what? Trig. So now we come here and write them down. First, your sign should start from plus and alternate. And what? You know what is alternation, right? Plus, minus. You understand? It starts from plus and it alternates down. Then this should be what? Your s cube, right? This should be your what? Sine. We agree, right? So what are you doing here? You are what? What are you doing here? Differentiating downwards. So let's go ahead and do that. This is 3x squared. 6x. So you must get to 0. You don't stop at what? A constant. After getting the constant, differentiate the constant, you must get 0. You understand? So the derivative part is where we are focusing on. In this liate, we focus on the derivative part. Are you understanding this? So we differentiate till we get to what? 0. So there are some cases where it might not work that way and we have a way to go around it, but at least that's like the basics. You understand? Now we come to what? This sine x. Sine x. What do? We integrate. What? What will you differentiate to get sine x? That's the meaning of the integral of sine x, right? So what will you differentiate? Minus cos x. Because if you say ordinary cos x should give you minus sine x. You understand? But minus cos x now, it will give you minus, the cos inside will give you what? Minus sine x, then attach the minus, it will not give you ordinary sine x. Do you understand that? So next, what is the integral of minus cos x? Are you sure? Sine x, if you differentiate it, it's not supposed to give you cos x. So it should be minus sine x. Please don't make mistake. Ask your question yourself that question clearly. What should I differentiate to get what? Minus cos x? Is this sine x? To differentiate sine x, I'm not supposed to get ordinary cos x. But this one is carrying minus. So since it's carrying minus, I'll attach minus to that was sine x. So if I differentiate this sine x, now I'll get cos x. But because of this minus, it's now become minus cos x. Please, are you following this thing? Are you understanding it? So here we have that. What will I, for me to get the integral of minus sine x, so I'll ask myself, what will I differentiate to get what? Minus sine x. Because I'm looking for the integral of minus sine x. So I'll ask myself, what will I differentiate? Beautiful, if you differentiate cos x ordinarily without any addition, you'll get what? Minus sine x. Then lastly, what will I, for cos x again, I want to integrate it. So it will be minus what? Sine x. Are you sure? Wrong. It should be ordinary sine x. Please ask yourself a question clearly. Please, after doing this, if you are confused, which I know you will normally be, come here and follow it backwards. Do what? Let me test if what I wrote is correct. Let me what? Test. Here, if I differentiate this, I should get the upper one. Differentiate sine, what will you get? Is it not tally? So it means that you are wrong. Because integral of this should be what I will differentiate to get this. So if I differentiate this, what will I get? Is it not tally? If I differentiate this, it's supposed to, ordinary sine is supposed to give me cos. But because the minus, it will give you minus cos s. If I differentiate this, it makes sense. Do you understand this? If you differentiate what? This is supposed to normally give you minus sign, but because of the minus, it gives you ordinary sign. So use this pattern to what? Check. You understand? So after differentiating, ensure you what? You check by what? Doing, the differentiation from what? Top, bottom to top. From what? Bottom to top. After that, what is the next step? You now trace the derivative to what? To the trig part diagonally. Do you understand it? Trace the derivative portion towards the trig diagonally, meaning the first term in the derivative should be traced down toward the second term in the trig. Second term here, traced down to third term. Third term traced down toward fourth term. Fourth term traced down toward fifth term. Are you understanding? This is first, this is second, this is second, this is third, this is third, this is fourth, this is fourth, this is fifth. Then what about the sign? Just link it up, horizontally. Link it up what? Link it up what? Horizontally. Now, all the parts that are left out after this diagonal tracing, which are this and this, I don't need it. I don't what? I'll trash it. I what? The table has given me what I need. The neighbors what? So now let's go. So it means that thus, you see how the answer will come out so sweet. Integral of x cubed sine x dx will be equal to, what will it be equal to? What sign is here? Multiply by this. This will give you what? 3, right? Multiply by this. Cos what? So let me write it in case some students are being confused. So you are multiplying. Are you understanding? You're multiplying this. Then after you finish multiplying, you go to the next row. What sign? Minus. Remember, multiplying again. Multiplying. So if you multiply, all you have minus 3x squared, then minus sine x. After that, you come here, which is what? 6x. Then you are multiplying and you are multiplying, which is what? 6x. Then cos x, right? Then you finally come here, multiplying and multiplying, which is minus 6 sine x. Please observe. Of what? Observe. We multiply this, and this. We get this, right? Then minus is because of the next rule. You understand? Minus is because of this. Then we also multiply this and this. You understand? Multiply all this with the sign. You will get this. Look at the minus is here, this is here, this is here. Of course, if I multiply this and what this minus, I will get plus, right? This minus will go out and go and meet this one to give you plus, right? You agree? Some might not be looking, and later they will ask me a question, but we'll bless God. Now, for us here, we have this multiplied by this, multiplied by this. There is no minus, so nothing will happen. Yes. Then finally, this multiplied by this, the minus here will show, right? Yes. Multiplying this, multiplying this. So let's clean it up. After cleaning it up, we're done. So here we have minus x cubed cos x, right? Is that not? Then this minus multiplying this. No, this is like saying minus 3x squared. Multiply minus what? Sine. It will give you plus 3x squared sine x. Then plus 6x cos x. Then minus 6 sine. Please, I want you to compare it with the first one we did. The normal integration by parts. If this is a short, I'll give you a link to what the first one we did in the description below. But if it's a full video, you should see it, right? Is this same? Any difference?
Sin x plus x plus x minus sin x plus c.
So that's all. So now let us what make it more tushed. More what? Tushed. Like I can reconfigure this answer. So look this format. If we have if we say let us leave this out, then factor out 3. What we have? Factoring out 3 from I say I leave this out, I factor out 3 in the rest. X squared, right? Okay, sine x. Someone might argue, why not I factor out x? But if you look, you will know why. You will know what?
No why.
So why am I not factoring out x? Since you have known why. Beautiful. God bless you for that. Because the last one does not have x. So this is the way I can write it. Are you understanding? This is left out. I factor out 3 here. This is remaining. I factor out 3 from here. Only 2x is remaining. I factor out 3 here. 2 is remaining. This is the one way. You understand? Another way I can write this, or I can say, bring the two cos together and factor out cos. It will become minus x cubed plus 6x, right? Cos x. Are you there? Then bring the sign together. Bring the sign together and have 3x squared minus 6 sine, that's outside now, sine x. Please observe. This was brought together with what? This. And I factored out cos, right? So I'm having minus 3x cubed, then this, right? In the brackets, right? Are you understanding it? Then finally, this and this was brought together. I'm having this and this, which is this and what? This. So this is another way I can write it. This is another what? Way I can write this. So thank you for watching this video. Like, subscribe, comment, and share. And see you in my next video. Bye-bye.